Hello guys, welcome to the second session of time and work. We already discussed three types of questions in the first part. Today let us take this fourth question and understand few more concepts in time and work. A can do a piece of work in 24 days. If B is 60% more efficient than A, then the number of days required by B to do the same piece of work is. So we have got four options and we have been given this data. A can finish a piece of work in 24 days and B is 60% more efficient. So by efficiency, we should understand that efficiency is given as work done by time taken. So to finish a particular work, how much time does a person take, and this parameter is nothing but the efficiency. So you can understand that here in this case the work is same. In fact, you can write it as efficiency into time taken is something which is constant, and this constant is nothing but the work here. For A, let us assume the efficiency to be this and time taken is this. Similarly for B, efficiency multiplied by that time taken. The product would be same because the product is nothing but the constant part, which is the work. And it is given in the question that B is 60% more efficient. So you can write efficiency of B is nothing but efficiency of A multiplied by the multiplying factor, which is 1.6, because it is given 60% more. 60% more is nothing but the multiplying factor 1.6. So you know efficiency of B is nothing but efficiency of A multiplied by 1.6. You can put it here back, efficiency of A and time taken by A as this. Efficiency of B is 1.6 times efficiency of A, and T2 is the time taken by the, and you can see T1 by 1.6 is T2. T1 is the time taken by A to finish the work alone, and that is given as 24. So the answer will be 24 by 1.6, which is 15. So B takes 15 days to finish the same work, working alone. Let us take the fifth question. A is twice as good a workman as B and together finish a piece of work in 14 days. In how many days can A alone finish the work? So we read about efficiency in the last question. When we say A is twice as good a workman as B, we are essentially saying A is twice efficient. So if B takes 2x days to finish any work, say W, A will take x days to finish the same work, working alone. And from here we can use the shortcut which we had learned in the question 1. Since two people are involved and one takes 2x days to finish a work alone and the other takes x days, so we can use 2x multiplied by x divided by their sum, which is 3x. This is nothing but the number of days which is given in the question that A and B together take to finish a work. This is given as 14. You can cancel out x here as x cannot be 0, and x will be 21. So A takes 21 days and B takes 42 days. Option C is the answer. Let us attempt another question related to efficiency. A is thrice as good a workman as B and takes 10 days less to do a piece of work than B takes. The number of days taken by B to finish the work is, as we discussed in the last question as well, that efficiency is nothing but the work done divided by the time taken. If A is thrice as good a workman as B, it is same as saying A is thrice efficient. And it can also mean that A takes 1/3 of the time that B takes to finish a job. So if B takes 3x days to finish a work, A takes 1/3 of the time to finish the same work working alone. Now this difference, this is B, this is A. Now the difference is 2x. A takes 2x days less than B. And this 2x is given as 10 days in the question. 2x equal to 10, x is 5. So B takes 15 days. 3 into 5. Option C is the answer. You see, this is a very direct question, but we can assume the variables as 3x and x to minimize our calculations. That's the learning from this question. Let us attempt the 7th question. If A takes 4/5 days as B takes, and working together they require 20/3 days to complete the whole work, what is the efficiency of B? If you can notice this 4/5 days as much as B takes, that's the number of days that A takes to finish the work working alone. So seeing the 4/5 fraction itself, you should start with B taking 5x days to finish the work and A takes 4x days to finish the same work working alone. And together they take 20/3 days to finish the entire work. From here itself you can use the shortcut which we learned in the first question. 5x multiplied by 4x divided by their sum, which is 9x, and this is given as 20/3. You can cancel out x as x cannot be 0 here, and you can write 20x by 9 is 20/3. This gives you x as 3. So B takes 15 days and A takes 12 days to finish that work. Since B takes 15 days to finish the work, the efficiency will be 1/15, and that should be your answer. Since the answer is given in percentages, we multiply by 100 and then append the percentage symbol. 5/3, 520. So the efficiency comes out to be 20/3%, and this is option A. I hope you understood the method. Let us take the 8th question of the series. A and B can do a piece of work in 8 days. B and C can do the same work in 12 days. And A and C complete it in 8 days. In how many days A, B and C can complete the whole work working together? So this question essentially gives us pairs, as in A and B together take 8 days to finish. B and C together take 12 days. And A and C, when working together, they can finish the work in 8 days. And finally our question is to find out, when A, B and C, all three of them are working on that same task, how many days will they take to finish the work? Let us assume A takes A days to finish the work alone, B takes B days, and C takes C days. assuming the work to be of 1 unit, we can tell that A's 1 day work is 1 upon A, B's 1 day work is 1 upon B, and C's 1 day work is 1 upon C. 1 day work of A, B and C respectively. Now let us fulfill the conditions which are given in the question. A and B together take 8 days to finish the work completely. So A's 1 day work is 1 by A, B's one day work is 1 by B, and this is 1 upon 8 for the first condition. Similarly for the second condition, 1 upon B plus 1 upon C, and for the third condition, fastest way to calculate is to observe 1 upon A here, 1 upon A here, 1 upon B, 1 upon B, 1 upon C, 1 upon C. So we add all of them, we'll get 2 times 1 upon A plus 1 upon B plus 1 upon C, and this will be equal to 1 upon 8 plus 1 upon 8 plus 1 upon 12. We can write twice of 1 upon A plus 1 upon B plus 1 upon C. 1 by 8 plus 1 by 8 is 2 by 8, which is 1 by 4. 1 by 4 plus 1 by 12, LCM is 12. 3 plus 1, this will give you 4 by 12, 1 by 3. And here there is a 2. So you can say that A, B and C, their 1 day work is 1 upon 6. If their 1 day work is 1 upon 6 and my complete work is 1 unit, I can definitely take that together they will take 6 days to finish the 1 unit of work, which is option B here. The other method could be to assume the work to be not of 1 unit but the LCM of 8, 12 and 8, and the LCM is 24. The LCM is 24. So A's 1 day work plus B's 1 day work will be 24 by 8, 3. Similarly, B's 1 day work and C's 1 day work will be 24 by 12, which is 2 units, and A and C's 1 day work will be again 3 units. So together, if you add all of them, all of their 1 day's work, you will get twice of A plus B plus C equal to 3 plus 2 5 plus 3 8, and you will know for sure that A plus B plus C is equal to 8 by 2, which is 4. 4 units they finish when they are working together in 1 day. Since our LCM has been 24 and they finish 4 units per day, they will take 6 days to finish the entire work working together. So this is how, if you take the LCM of the numbers involved to be the work units, you would not need any reciprocals or fractions and their sum, which would make the calculation a bit more tedious. You can simplify using this LCM rule. I hope you understood the 8th question as well.